Okay, all right. We will go to chapter number 3, frequency modulation. Okay, so frequency modulation is the third chapter for this topic. Okay, so we have seen the first two chapters before this. For the thing, we concluded yesterday, chapter 2, and before this, we have seen chapter 1 as introduction. Okay, we will go into the frequency modulation. Frequency modulation is a bit different from amplitude modulation, which is we covered in chapter number 2. Okay, so principle of FM meaning frequency modulation. Okay, so amplitude modulation is AM. Okay, so we can see here we have some read up. Sine wave carrier can be modified for the purpose of transmitting information from one place to another by varying its frequency. This is known as frequency modulation. So, firstly, we need to understand what is frequency modulation. So, we can see in the figure here. Okay, so this is a carrier signal. So, carrier signal normally will be the same. So, it's just a waveform, so which has no information, and this is your message. Okay, so let's say the message is in the form of this waveform like sine wave. Okay, so you want to attach this message signal into the carrier signal for you to transmit. Okay, so we have seen in amplitude modulation. So the modulator signal, when you mix the message signal, you add message signal to the carrier signal, so it will follow shape, the shape of the message. But if you see in the frequency modulated signal, so the place where the amplitude is high, so it will be closer. Okay, and where the place you go in the negative form, so you can see the distance between the peak to peak is a bit like far. Okay, so we can see by varying the waveform to be near and a bit far from each other, so you can have a frequency modulated signal. So that is what he is saying. Okay, so in frequency modulation, the carrier amplitude remain constant. So meaning it will be the same height. Okay, so it's not varying in terms of the amplitude. So the amplitude will be the constant, but what will vary? The frequency. So when the waveform is near, so the frequency is higher. When the waveform is far, the frequency is lower. So frequency modulation is utilizing this concept. Okay, so your amplitude will not change. Okay, so the main aim of the modulation is to transmit information from one place to another by using the frequency. Okay, so comparison between the waveform. So AM is amplitude modulation. So you can see. So this is a message signal. So let's say this is a message signal. So amplitude modulation, the signal will vary according to the high and low of the signal. Okay, so it will follow the shape. But in frequency modulation, so since this is positive, so it will be closer, and when it go down, so it will be a bit far, and when it goes up again, it will become closer, but the amplitude are the same. Okay, so you can see the difference between AM and also FM. Okay, so nowadays we are not really using AM. Okay, so very limited. So usually we will go to FM. So even our radio frequency, so we can tune in the car. So we can have certain frequencies that we can set to listen to certain channels. Okay, so we are more into frequency modulation now. Okay, so we see some of the info. As the amplitude of the information signal varies, the carrier frequency shift proportionally. So as we can see from this picture, we already discussed on this. When the amplitude is positive, is nearer. So when it goes down, so it become a bit far. Then when it goes up again in positive, it will be near, and when it goes down, it will be far. Okay, at the modulating signal amplitude increases, the carrier frequency increases. So I think I already explained this. So with no modulation, the carrier is at a normal center or the resting frequency. So like this. So no modulation happens. So it will keep on going in the same height, same amplitude, a positive and also negative. So we call it as a normal center, or it's a resting frequency. Okay. Okay. So we have a frequency deviation. So we write it as FD. Okay, what is frequency deviation? It is the normal amount of change in carrier frequency produced by the modulating signal. Okay, so it happens when you are mixing with the message signal. So carrier frequency you join with uh, message signal, so you can have a frequency variation. So that is what we call as a frequency variation. So the amount of changes in the carrier frequency. Okay, so it will change the modulating signal or the message signal into our frequency modulated signal. The frequency deviation rate. Okay, so if it involves rate meaning per time. Okay, so it can be per second, per minute. So usually for FM, we will calculate per second. Okay, so even our internet connection, Mbps. Okay, millibyte per second. Okay, so it is actually referring to the rate. Okay, so frequency deviation rate is actually how many times per second the carrier frequency deviate above or below the central frequency. So central frequency, as we can see, so this is the central frequency. So you can see, so how much it varies compared to this, and how much. So this part it varies more. So we can get the rate in 1 second. So how many times it changes. Okay, so that is what we call as a frequency deviation rate. The modulating signal frequency determines the frequency deviation rate. Okay, so it depends on your message signal actually, the frequency from your message signal. So if your message signal varies more, so the frequency deviation rate will be more. Okay, so it depends. Okay, so applications. Okay, a type of modulation called frequency shift keying, or we call it as a FSK, is used in transmission of binary data. So binary data we know 0 and 1. So usually our phone, so whatever digital devices, okay, so digital devices is using zeros and one, a combination of zeros and one. So that's what we call as a binary data. So even our computer, our digital TV, so everything are using binary data. Okay, so if it's using binary data, so it's actually applications. So a lot of applications are using binary data. So if you are using binary data and you want to send from one point to another point, so we need to use a modulation called frequency shift keying, or FSK. Okay, so it is mostly in the digital cell phones and also low speed computer modems. Okay, so I don't think you all have experienced the low speed computer modems last time. So we call it as a dial-up connectors. So we always it's connected to your phone line. Okay, so if you are using this low speed computer modem, so you cannot use the phone. You need to switch. So the phone line will be used as a modem. It's a modem connection. So when you are using this, so you can see the term frequency shift keying in your setup. Okay, so what is a FSK? So let's say this is your binary input. So binary input normally 0 or 1. If 0, it will be 0 voltage. If 1, it will be 1 voltage. So you can see how it's changing. So when it's is the value increases to 1, so it will be closer. When it goes to 0, it is a bit far, and when it goes up again, it's nearer. So it will have the combination of this kind of output wave. We call it as a FSK modulated output wave. Okay, so we are not going to discuss on this more. So it's just like an application of frequency modulation. Okay, because it's dealing with the frequencies. Okay, so frequency modulation. So we have seen some of the info as an overview. So we continue by reading. So FM modulation is a process in which the frequency of the carrier is very varied in accordance to the instantaneous value of modulating signal. So it depends on the instantaneous value, meaning so value at that time. Okay, so let's say this is your signal. So the instantaneous value at this point, so it can be maybe 0.5. So that is what we call as a instantaneous value of the modulation signal. Okay, so as it goes down, so you can see, so it started to have more gaps. So when it go to negative, it's more gap, and when it started to go up, it started to get closer. So it can have compression and also uh, s- suppression and also expansion of the waveform. Okay, so information you can attach in between. Okay, the amount of change in frequency is determined by the amplitude of the modulating signal. So as I said before, so it depends on how high the uh, instantaneous value in the signal. So frequency modulation is a process of varying the frequency of the carrier signal linearly with the message signal. Okay, so we are modifying, you are utilizing the frequency changes in the system and in the waveform. In frequency modulation, the amplitude and the phase of the carrier signal remain constant. Okay, so you can see the amplitude same. Okay, so not changing in amplitude. Phase also not changing. So meaning uh, is not really when it, because when we compare with amplitude modulation, when it go below 0, the phase change to 180 degrees. Okay, 180 degrees. So but in frequency modulation, no phase changes, so changes remain constant. This can be better understood by observing the following figure. So you can see here to understand it better. Okay, so some mathematics. Okay, similar like amplitude modulation. So we need to have some mathematics in between. Okay, in behind of the concept. Okay, so you can see the equation of the instantaneous frequency Fi in FM modulation is, so F FC we know is a carrier frequency. Uh, KF KF or KT. Okay, because it's related to time. So it's a frequency sensitivity. Okay, so Fi is the instantaneous frequency. Okay, so this is the equation to calculate. Okay, you can calculate the instantaneous frequency for the waveform. Okay, so in relationship with angular frequency, so you are dealing with angular frequency. All these are derivation, so we are not going to derive. We just want to use the final formula, but just for your understanding. Okay, so it's related to angle, the angle in between. Okay, so omega equals to the phase, the angle, changes in the angle over time. Okay, so omega is 2 pi f, so 2 pi fi, so instantaneous uh, angular frequency, so equals to the angle over time. Okay, so you can rearrange in order to form this equation. Okay, once you form this equation, we will replace. Okay, substitute Fi value in the above equation. So Fi is actually from this formula. So this formula you are replacing inside this formula in order to get this. Okay, so once you get this, you expand. So it's already factorized. You expand it to form two components, 2 pi fc t, okay, plus 2 pi kf integration of the message signal. Okay, after you substitute the values in the standard equation of the angle modulate. So frequency modulations, we have a angle modulated wave. So this is the standard equation. Okay, st equals to ac cos angle with in respective of time. Okay, so um, we try to you already find the angle in terms of time. So you are replacing this value inside this standard equation. So once you replace it, so you will get this formula. You can see AC here, cos, so angle T, so angle T is this. So we are putting this inside. Okay, so we further derive. So if the modulating signal is empty, empty equals to AM cos 2 pi FMT. So this is your modulating signal, your message. Then the FM equation of FM wave. So you are replacing empty. So earlier you have empty here, empty. So you are replacing this message inside this. So after you solve it, you will get a formula like this. St equals to AC cos 2 pi FT FCT plus so this is a modulation index sine 2 pi FM T. Okay, so we know the modulation index for FM is the changes in frequency over modulating frequency, and we can get KFAM over FM. Okay, so it depends on the questions later. So if the question asks you to calculate the modulation index, so you just replace into this formula to get. Okay, you don't need to derive. I don't need to derive. Derivation is only for your understanding. The difference between FM modulated frequency, instantaneous frequency, and normal carrier frequency is termed frequency deviation. Okay, so the difference. So normally we already have a normal carrier frequency. So when you are attaching a message signal inside, so you can have certain changes, so which will determine the frequency deviation from the original signal, original carrier frequency. So it is denoted with changes in f, which is equals to the product of kf and am. Okay, so you can see changes in f is kf am. So product means is times. So FM can be divided into narrow band. So there are two types of frequency modulation. We call it as a narrow band. Okay, narrow, is very limited, and we also have a wide band frequency modulation. So it depends on your application. So where you want to apply. So different application. So maybe certain applications you only requires narrow band. So certain applications requires a wide band. So depends on the application, then you determine. Okay, and the difference between narrow band and also wide band is the value of modulation index. So beta. Okay, so we see a little bit info on narrow band. So narrow band frequency modulation. So some of the features. So this frequency modulation has small bandwidth when compared with wideband FM. So bandwidth meaning so maximum frequency minus minimum frequency. So this we already covered in chapter 2. So narrow band, the frequency will not be it will be a bit near. So maybe between 500 to 1000. So it's very narrow. So we can have that kind of comparison for narrowband. Okay, wideband, it may be a bigger frequency, 0 to 8000. So you have more range. That's why we call it as a wideband. Okay, the modulation index beta is small. Okay, so small because the f max minus f minimum frequency is smaller. So usually the modulation index will be less than 1. Okay, so its spectrum consists of the carrier, upper sideband and lower sideband. So you can see here. So you have a central frequency. So you have a lower sideband and also upper sideband. But you can see only very limited because it's very near the frequency. Maybe like I say 500 to 1000. So it's only maximum to minimum is only 500 hertz. So it will be considered as a narrowband. So this is used application wise in the mobile communication like police wireless, because we don't need to have a lot of frequency. So that's why normally they will tune the frequency. They only use one frequency. So they don't need to have a lot of frequency band. So you can use in a police wireless. You can use in ambulance, taxi, cabs, or etc. So the application mainly something that is using very fixed frequencies. So which we use a narrowband FM. Okay, then we have a wideband frequency modulation. So wideband is something that we can see in the radio communication. Okay, so radio communication. Okay, so these are the features. So you can see wideband. So you have a central frequency in between. Okay, the middle. So the other side, okay, the lower side, you can see there are a lot of frequency band, and upper side also it has a lot of frequency band. So compared to narrow band, it's very limited. Only has two lines, two line on the left, two lines on the right. So here the central figure you can see 1, 2, 3, 4, 5, 6, 7. Okay, or 7 or more. So it can be more. So this frequency modulation as an infinite bandwidth. So because it has more frequencies in between, so the modulation index beta is large because f max minus f min is bigger. Okay, so usually the value will be more than 1. So a spectrum consists of a carrier and infinite number of sidebands which are located around it. Okay, so here only you can see 7, but it actually can have an infinite number of sidebands. Can have as many as you want. So we have seen an amplitude modulation. So the carrier frequency is not carrying any information. So your message signal will be attached to the upper sideband or lower sideband. Uh, so the informations are there. So when you have infinite number of sidebands, so meaning you can store a lot of information. Okay, and it will be around the central frequency. Okay, so that is the reason why it is used in entertainment. The entertainment you can see, even our one movie. In the movie, you can see suddenly the frequency goes up, suddenly it become low. So a lot of variance. So it can carry more information. Okay, so broadcast application like FM radio. So even our FM radio, we can see in the car. So it varies from 88 megahertz until 108 megahertz. So it has a very wide range of. So you can put channels in between. So channel, so let's say it's 96.4. So it's FM. So you can, so that channel can use that particular frequency. So a lot of frequencies, a lot of channels can be in between. Okay, so even TVs and etc. Okay, so bandwidth calculation. Okay, so for FM, they usually will calculate using Carson's law. Okay, so I'm not really going through this because it's more on the radian per second, but we are more interested in the hertz because it's a frequency. So we can see once you conducted this, so you can get this bandwidth calculation in terms of radian per second. So in this form, so once you solve it, so 2 changes in omega 1 plus 1 over modulating frequency. Okay, so if you change it, okay, so modulating frequency is actually the modulation index. Okay, so the changes in omega is actually changes in the frequency. So you can replace this information inside this formula in order to get this formula. So bandwidth for frequency modulation is 2 times changes in frequency or the frequency deviation times with 1 plus 1 over modulation index. So the formula will be calculated in hertz. Okay, hertz. Okay, so these are some of the calculations already available for you to use. So we call it as a Bessel function. So Bessel function, so we can calculate some value of modulation index. So you can see modulation index already have many modulation index, and you can have a carrier frequency, different types of carrier frequencies, and you can have other sides frequency pairs. You can see there are many types. Okay, many types. So when the modulation index is 0, so carrier frequency is 1. So meaning, so no information is attached, so no other bands are involved. So when the modulation index is bit lesser, so there are more information, already start to have information. Okay, so it's just like for your understanding. So we can use this Bessel function, so which already calculated before by the engineers. Okay, so you can just refer to this chart in order to determine so what are the frequency pairs that you can use. Okay, for your, so you no need to go through the whole set of formula to calculate. It's already calculated for you. For our syllabus, we are not really calculating this, so it's just for your understanding. Okay, so advantage of frequency modulation. Okay, so of course compared to amplitude modulation, so FM has more advantage. Okay, so first advantage is it gives noiseless reception. uh, so noiseless reception, meaning so no interference in between, unless you are in a zone where interference happen. So even you are using a radio in the car, so you just on the FM. So you can see if the area is clear, so the noise will not be there. So the you can hear whatever broadcasting in a very clear voice. Okay, so it will be very clear for you. Okay, so the noise will be a bit less. Okay, a bit less. So compared to AM, so noise is a form of amplitude variation, and FM receiver will reject such noise signal. Okay, so it has a very clear cancellation criteria. Okay, inside your FM receiver. So when noise happens, so noise in the form of amplitude variation, suddenly it goes up, suddenly goes down. So it can detect and it can reject such noise signal. So for daily life application, the FM is more preferred. Okay, then the operating range is quite large. Okay, so we can, so like how I can give the example of the radio. So between 88 megahertz until 108 megahertz, you can see so many channels, maybe 20, 30 channels. It can use a particular frequency. So if you want to listen to the radio channel, okay, so you just need to turn to that particular frequency, then you can already hear. Okay, so the operating range is quite high, and the efficiency of transmission is very high. Okay, because more information can be carried. So the quality of the message transmission is quite good. So that's why we say it's highly efficient. Okay, so power consumption is less compared to AM. Okay, so this in terms of power consumption. because less friction. So when less friction, so you can transmit the message faster. Okay, similar like how you are driving. Okay, so driving from one place to another place. So if no friction means less jam. If less jam, you can reach faster. So you no need to use more petrol. Okay, similar. So the power consumption will be less. Okay, compared to AM. So AM we have seen if one suddenly there are some interference inside, so the output message can be different from what you are sending. Okay, so adjacent FM signals are separated by guard bands. Okay, so let's say you can see this picture. So let's say this is your the FM first FM station. Okay, so it's operating between this F max to F min. Okay, so station one. So in between you have a guard band. So you cannot see 92.4 is its FM. So 92.5 is odd FM. So you won't have like that. So in between you'll have a guard band. So where no channel or transmission can happen in that zone. Okay, so you have a guard band. So after the guard band, then you can have the second station. So similarly, between let's say you have 20 stations using that band. So in between the 20, so you will have 20 guard bands. Okay, in order to separate, so that it can keep things very clear. Okay, no interference between one channel to another channel. So of course we will be annoyed, right, as a user. So you want to listen to it FM, suddenly odd FM is entering. So it will the experience will not be good. Okay, so some there, even though there are more advantages, so you can see there are so many advantages, but there are disadvantages of frequency modulation also. So the disadvantages are not so crucial, because at the end we want a quality transmission, so we don't want an error. So this disadvantages, so is understandable. Okay, understandable, and we can still accept. Okay, it's not so bad. Okay, but the disadvantages are there. Okay, first thing is a much wider channel is required for FM. So you cannot send in very small. Let's say you have a lot of FM channels, so you cannot send in a narrow band. So you need to have a wider band. Okay, so compared to amplitude modulation, so FM requires a wider channel. Okay, then you FM transmitting and receiving equipment tends to be more complex. Okay, so it can be more complex because you are dealing with more circuits, which can make the equipment to be more complex. Okay, so when things are more complex, of course the cost will be higher. So everything are related. So everything are related, and it has a large bandwidth. So the maximum frequency and also minimum frequency, unless you are using a narrow band. But narrow band you cannot use for most of the applications. Only like selected applications like police, walkie-talkie. So all that are using a narrow band, but we cannot use that frequency to send radio signals. Okay, so you need a large bandwidth. Okay, so the antennas of FM systems should be kept close for better communication. So you need to keep it close, but of course we want to send it to a very far place, so you cannot use a small antenna. So you need to have a very large antenna in order to send between states. So between, that's why usually the radio stations, so you will have antennas on the eels. So this zone will use a different frequency. So another zone will use a different frequency, so that we try to give a uh, good service to the end users, which is us. Okay, so we, of course, these disadvantages can be overcome with the mitigation plans. Okay, so AM versus FM. Okay, so amplitude modulation. So we can see the frequency and pace remain the same. Okay, so amplitude modulation, we are not changing the frequency, and we're changing the amplitude. But in frequency modulation, so we are changing the frequency, amplitude, and the phase remain the same. Okay, so it can be transmitted over a long distance, but as poor sound quality. So of course, amplitude modulation you can send to very far place, but as far as it goes, the sound quality will become poorer. Okay. So in the frequency modulation, it has a better sound quality with higher bandwidth, because you have more frequency in between, so you can play around with the sound quality, so you can improve the sound qualities. Okay, so the frequency range varies between 535 and 1705 kilohertz. So you can see the difference here. We are using megahertz. Megahertz meaning millions of hertz. Here we are only using kilohertz, which is thousands. Okay, so the frequency range is smaller for FM. So we are starting from 88 megahertz until 108 megahertz. That's why even your radio channels in the car, when you tune, so it will be between 88 to 100. And mainly it will be covering the higher spectrum of electromagnetic wave. Okay, so signal distortion can occur in AM, so meaning signal effects. Okay, so there can be a lot of noises that can affect the AM signal. So when it affect, so for you to get back the original message can be a bit challenging. But in FM, so less instances of signal distortion. Distortion is very less. Okay, in FM. So not to say don't have, but it's lesser than AM. So which will be an advantage. So it consists of two sidebands. Okay, so we saw a lower sideband and also upper sideband. All the information is inside. But FM, it has an infinite number of sidebands. So there are many. So it can be infinite, any number. Okay, so circuit design is simple and less expensive, because it's not really giving a good quality. I can send over a distance, uh, and the circuits are only covering certain frequency. So the circuit design is a bit simple. When it's simple and not complex, so it can be less expensive, so cost effective. But FM, it is very intricate and more expensive, meaning it's more complex. So when more complex, it will be automatically become expensive. And AM is easily influenced by noise, while FM is less influenced by noise. Okay, so there are certain application you still can use AM, and most of the frequencies the applications now are using frequency modulation, and we already have many other modulation, and mostly everything sent through digital now. Okay, so we have other types of modulations as well to covering the digital aspect. Okay, okay, so you can see some of the questions related to this topic. Okay, frequency modulation. So I expect you to try it yourself. So you can see some of the calculations which can be asked in the midterm or final. Okay, so the calculation portion. Okay, it's not so hard. So all the you just need to use the formulas given. Okay, in order to calculate. So like here, the first question, determine the percentage modulation of an FM wave with a frequency deviation of 10 kilohertz if the maximum deviation allowed is 25 kilohertz. Okay, so that's the first question. So you can try it yourself first. Later, after we finish uh, most of the chapters, then we will have tutorials. And during the tutorial, we will see. So we will try to discuss on and these questions. The second question, in an FM system, if the maximum value of deviation is 75 kilohertz and maximum modulation frequency is 10 kilohertz, calculate the deviation ratio, okay, and bandwidth of the system using Carson's rule. The Carson's rule we have seen earlier, so we can see, we can try to apply it. Okay, it's just like few steps in order to get the answer. I want you to try it first. Okay, so try it yourself. 3. So use Carson's rule to compare the bandwidth that will be required to transmit the baseband signal with frequency range from 300 Hz to 3 kilohertz using. So NBFM is a narrowband FM. So maximum deviation is 5 kilohertz. And wideband, so we have a maximum deviation of 75 kilohertz. Okay, and fourth question, the carrier frequency of an FM broadcast transmitter is 100 megahertz and maximum frequency deviation is 75 kilohertz. Is the ratio the or IS audio frequency modulation carrier is 15 kilohertz. What is the approximate bandwidth? So mostly the questions are just they give one value, ask to find another. In the other questions, they give other value and ask to find the other parameters. So I think it's doable. So I hope you can try. The fifth question. So a single tone FM signal is given. So they already gave FM signal as the modulated FM signal. So FM signal meaning is already modulated, a frequency modulated signal. So they asked to find the modulation index. So you just need to compare with the standard formula. So the modulation frequency. So you need to extract from this given signal, compare with the standard form. So the frequency deviation, carrier frequency, and also power of the frequency modulation. Okay, so try these 5 questions for frequency modulation and also for amplitude modulation. So we have other sets of try it yourself questions which you can try. Okay, so summary of chapter 3. So frequency modulation we are not really discussing much because it's almost the same like amplitude modulation. So amplitude modulation we already discussed many things. So for frequency modulation, most of the things are the same. So that's why we are not really repeating. So we only discuss some important the principle behind the frequency modulation. Okay, the mathematical expressions of frequency modulation. So the advantages and disadvantages of the FM modulation and also the comparison. Okay, so mostly you need to understand how what's the difference between AM and also FM. Okay, because it's quite famous question in the exams and the test. So ask you to compare. So you need to give the points. Okay, so the comparison points. Okay, so any questions? Okay, before we finish.
No, sir.
Yeah, I think
No,
some
sir.